In today's video, we're going to look at a KCL, KVL, and voltage divider. And also current divider. So let's start with KVL. What is a KVL? It's a Kirchhoff voltage law. It stands in any complete circuit. The algebraic sum of voltage equal the algebraic sum of voltage drop. And voltage divider is how we find the voltage for each resistor. When we have series circuit. So let's say if we have a circuit like this, this is a power source, E, R1, R2, R3. So I say E equal 120 volts, R1 equal to 20 ohms, R2 equals 10 ohms, R3 equals 30 ohms. I find the voltage for each resistor first. I say V1, if we use voltage divider, it will be R1 divided by R total, which is R1 plus R2 plus R3 times E. That will give us 20 ohms divided by 20 ohms plus 10 ohms plus 30 ohms times 120 volts. That's how we use voltage divider. So that will give us 40 volts. V2 will equal to R2 divided by R1 plus R2 plus R3 times E, which will give us 10 ohms divided by 20 ohms plus 10 ohms plus 30 ohms times 120 volts. That will give us 20 volts. V3 equals R3 over R1 plus R2 plus R3 times E, which is 30 ohms divided by 20 ohms plus 10 ohms plus 30 ohms. That will give us times 120 volts. That will give us 60 watts. So basically that's how we use a voltage divider to solve the voltage. We can also, the other way to prove our answer is we find the RT first, get IT, then we can find the voltage for each one by using Ohm's law. So let's do it another way. Okay. So RT will be R1 plus R2 plus R3 equals 20 ohms plus 10 ohms plus 30 ohms, which gives us 60 ohms. For IT, since it's series circuit, IT equal to I1 equal to I2 equal to I3, that will give us E divided by RT equals 120 volts divided by 60 ohms. That's 2 amps. So V1 will be I1 times R1 or IT times R1 equals 2 amps times 20 ohms, 40 volts. V2 will be I2 times R2 equals 2 amps times 10 ohms, which is 20 volts. V3 will be I3 times R3 equals 2 amps times 30 ohms, which is 60 volts. So that kind of prove our answer for voltage divider. By using just the Ohm's law. So for KVL, basically said in a complete circuit, the total voltage equal to the sum of the voltage drop. Basically, it's V1 plus V2 plus V3 equal to E. So if we have one unknown, we can use the subtraction. Let's say if V3 is not unknown, we can use E minus V1 minus V2 in order to find the V3. So that's how to say KVL, how we use KVL to solve the electrical circuit. Now let's look at the KCL and current divider. So for KCL, it's a Kirchhoff current law. It said at any junction in a circuit, the algebraic sum of the currents entering the junction equals the algebraic sum of the currents leaving the junction. Okay, what does that mean? So basically, if we have a point here, we have the current entering that junction, and we have the current leaving that junction. Let's say this is the direction of the current. This is for entering, let's say I1, I2. We have I3, I4. So whatever entering that point, it's I1 plus I2 equals the current that leaving that junction is I3 and I4. So the sum of the current light entering that point equal to the current that leaving at that point. So that's KCL. How we use that? So let's say if we have a parallel circuit, something like this. Let's say this is R1, this is R2. This is E. Here we have IT here, I1, I2. This is node X. Let's say E equals and IT equals 12 amps. R1 equals 10 ohms. I find the value for R2, I2, I1. These are unknowns when you solve for these. Okay, so we have parallel circuits. The voltage for R1 equal to the voltage for R2 equal to the total power E, or total voltage E. So I1 will equals E divided by R1. This is the Ohm's law. Okay, which will give us 50 volts divided by R1 is 10 ohm. That's 5 amps. Now we use KCL. At node X, the total current entering the junction SIT, and the total current leaving the junction is I1 plus I2. So if we look at the circuit, so at this point, this is IT. So leaving is I2, which is this branch, and I1, which is this one. So IT, if you use the current KCL, IoT equals I1 plus I2. So we have IT now, and we'll solve for I1. So I2, this is our original KCL. IT equal I1 plus I2. So for I2 will be IT minus I1, which will give us 12 amps minus 5 amps, that's 7 amps. So now we get the current for resistor R. In order to solve for R, we can use Ohm's law. R2 equals E divided by I2, which will give us 50 volts divided by 7 amps. Which will give us 7.14 ohms. Now let's look at the other circuit, something like this. So R1, R2, this is the power, E. So let's say voltage E equals 10 volts, and R1 equals 5 ohms, R2 equals 10 ohms. So by looking at this circuit, they in parallel, we can solve for RT first. RT will be 1 over R1 plus 1 over R2 equals R1, R2, R1 plus R2, 1 over. Then we can flip the number, R1, R2 divided by R1 plus R2. That will give us 5 ohms times 10 ohms divided by 5 ohms plus 10 ohms. So that will give us 10 over 3 ohms. So for IT will be equals E over RT. That will give us 10 volts divided by 10 over 3 ohm, which is 3 amps. Now let's look at the current divider. So basically for parallel circuit, the voltage are the same everywhere. How do we get voltage? By using Ohm's law, we can get IT times RT equals I1 times R1 equals I2 times R2. So right now we have RT, IT, we have the resistor for R1. How do we solve for I1? If we have Z2, so IT, RT equals I1, R1. How do we find I1? So I1 will equals IT times RT divided by R1. So we have IT equals 3 amps times RT is 10 divided by 3 ohms divided by R1 is 5 ohms. So that will give us 2 amps. I2, same thing, it will be IT RT divided by R2. So that will give us 3 amps times 10 over 3 ohms divided by 10 ohms. That will give us 1 amps. So basically this is the formula for the current divider. If we have more resistors, let's say if we have 3 resistors, we can just use R1, R2, R3. So we get RT, so it'll be IT RT divided by R1. That for I1. I2 will be IT RT divided by R2. I3 will be IT RT divided by R3. So this is a kind of current divider. That's basically just Ohm's law, the other form for Ohm's law. Ohm's law, we have V equal to IR. So E is the total voltage, so it will be ITRT. After we get the total voltage, since the voltage are all the same for them, so that's V. So the current will be I equals E over R1, or for I1. I2 will be E over R2. I3 E over R3. So basically they all kind of related to Ohm's law. That's everything for today. Thank you for watching.